Hello, this is Luca from 2624C. This is our post-Worlds robot explanation video. We are juniors. My team's currently juniors, so this is our third robot, although as a team, this is our second year competing. We had a pretty good season. At Worlds, we went 8-4, and we were chosen by our friends. Lost in round of 16, unfortunately, but it was fun. We learned a lot, so I thought I'd make a robot explanation video to kind of show this robot. It's pretty different than what you'd see everywhere else. We kind of like to stay a little bit off meta throughout the season, even though this design hasn't really changed much. There's quite a lot going on, so I'm gonna film this in a couple parts. But as you can tell, like I said, this isn't really what you see everywhere else. It's definitely not like an S-bot. It's kind of more of a D-bot, but I'm going to go ahead and start by talking about the drivetrain. All right, so starting off with the drivetrain, we actually used a 55-watt drivetrain, which is pretty different than what everybody else used. Most people used a 66-watt drivetrain. We did this for a couple of reasons. One was primarily that we kind of struggled to only use 22 watts for everything else that we wanted to do on the robot, because we kind of had this design before we started building. Everything was mostly CAD'd first and kind of drawn out. And secondly, we kind of just wanted a little bit of a challenge. We did 66 watts last year, and we felt it would be kind of cool to use 5.5 watt motors in the drivetrain. And this is actually kind of good because I think a lot of people are going to be doing a 55 watt drivetrain next year for override due to the limit. So yeah, I'll go ahead and flip this over. So in the drivetrain, we have our two 11 watt motors on either side here. These are connected to 36 tooth gears. And then this is a 48 tooth gear. These are the half ones, and then these are the full, which are kind of sandwiched in between the wheels. We used full Omni wheels on this. I kind of, as a driver, like having full Omni, and we didn't really have much of a problem getting pushed because this robot is quite heavy, unfortunately, which I think was a design flaw, but it kind of prevented teams from pushing us around when we were locked against the bar. The interesting part about this drivetrain is the 55 watt. So we have two on either side, obviously. And the way we made this work was by having the axle back here. It's mounted on this bearing, and that's connected to its own 36 tooth gear. And because these have an output of 200 RPM, and then these are running on blue cartridges, which is 600 RPM. So it's a 3x difference. So this is a 12 tooth gear, this is a 36, and that essentially just meshes the RPM from the 5.5 watt motor to the rest. This has to spin in the opposite direction though. And we did have a little bit of trouble with friction at the beginning because having motors that spin at different velocities can be a little bit tricky if you don't have like a constant output for voltage. So our programmer Nahem actually created a custom PID loop for voltage, which helped a lot. So for structure, we had 4 cross channels, only 2 of which were actually full length. These 2 were kind of added later after we built the drivetrain. For the rest, that's kind of going on over here with these, that I'll explain in a bit. These were nice. We didn't really have any problems with the drivetrain kind of moving in a way we didn't want it. It's a 5 wide, so everything is very tightly packaged, and then we used screw joints for the wheels, and then of course axles for the motors. And then here we have our Odon pod. Earlier in the season, the friction on this is actually not very good right now. It's kind of stuck because we had a lot of collisions at Worlds, but this worked really good. The friction on it was great. Well, at least while we were using it, it didn't really have any problems. We actually overlapped these. You may have seen a couple other teams do this, essentially having the holes kind of line up so that the profile is a bit more round. There's a couple different ways you can do that, but this worked for us. This was 2 poly pieces. We definitely could have done it without, but we chose to use poly for that, which we CAD'd. Then we have our sleds here, which is a curved design, and then they are kind of reinforced right here with wall riders. What else? We have these L channel pieces right here. There's one right here and one right here. And because we're missing a wheel on this section of the drivetrain, we realized that we didn't want to have a hole. So we actually added this, which is kind of like a continuation of the sled poly. And we have that as well here to just cover the gap that's created from the profile of the wheels. So overall, the parking worked really well, and the drivetrain was good. Not too many problems. This stayed pretty standard throughout the season. All right, moving on to the intake. We have a multiple part intake. We have this bottom section and this kind of funneling system, which I'll talk about in a second. This part is probably my favorite part of the robot. This was really difficult to make. We made this right after Worlds last year. We made this out of cardboard to start, and then we kind of had a lot of iterations of the geometry of this piece. We used a single acting piston for this, even though these are actually the newer double acting. We just did it to save on air. So it's active out and then passive in. These are pretty cool, honestly. And then I can show you how those work. So they come in like this. This is a little bit broken. These are half-cut gears, which is kind of why you can kind of hear them wobbling. I think the spacing here was a little bit messed up after a couple of collisions because of that axle being bent. But these come out with air, and these are actually both powered by an individual 5.5 watt motor, which are sandwiched all the way back there. So let's see if I can show this a little bit better. The 5.5 watt is right there, and that chain spins like that. This was built before everything else, so it wasn't super difficult to get them in there. Originally, they were a little bit closer up front, but then once we added this structure, we had to move them back and conceal them a little bit more, which ended up working to keep our center of gravity quite low. So this works really well. You can see there's a couple videos of it on our main page if you go check that out. These are pretty fast. They worked well for us, and they also kind of worked as funnels for balls. So when we were scoring normally, we had these kind of spin slowly, like that. And that essentially just allowed the balls to go in a little bit, which helped for scoring. And this also helped for alignment for the goals, because this is a front-to-front robot. So we intake at the front and then score at the front, which a couple teams have mentioned could be a little bit slower. Although for wing play, I actually noticed this was a little bit better because I could just back out and then turn around, whereas a lot of other teams often would have to either back out and then turn around, or back out and then drive backwards, which often was a little bit more difficult for newer or a little bit less experienced drivers. Then the second part of this intake is this. This is hinged up and down. Again, this is all kind of jaggedy because there's a lot of collision, so this up here is bent. But this was just hinged, nothing super special about this. That's connected to 3 rollers. So we have this rubber band roller right here, rubber band roller right here. And then the cooler part about this is we actually have 2 flex wheels, which act as a intermediate stage. So these both spin independently of each other. They're chained down from the 3rd axle, which is right here, powered by this 11 watt motor. So right here, we have a sprocket that's connected up to this one. So this is 2 to 1, and then here, this is 1 to 1. So this is spinning the fastest, which just helps kind of funnel things back into the basket. This worked really well. We had a couple issues with jamming down here. Sometimes balls would get stuck right there, especially if you didn't have enough speed. But going all the way through wasn't too much of a problem. This was actually an addition right before Worlds. Before we had one of these, except they were just a little bit larger with those older green sprockets. But we realized that this works a lot better for scoring because it kind of keeps the balls in a straight line. So they can't really move to the side much where they could if it's just like a roller like this. So scoring was cool. It's kind of just like a flap that you would see on a lot of other robots. This flap was inspired by a couple teams that used those basket mechanisms. We actually bent an L channel for this, which was kind of cool. And then we have hard stops here and here. And this is pistonized back here from the smallest piston. This is actually double acting, even though it's rubber banded down. This takes up a good amount of air, not as much as these, but this obviously had to be active the entire match for scoring. So we chose to make this double acting because this is kind of the largest source of the air. So again, that just kind of goes up from scoring. So when this is in the down position, here, let me grab the ball real quick. Balls will funnel all the way through, kind of like that, and then they end up in the basket over here. Now, we actually have a secondary roller right here. This is what controls the flow of balls as they come out this way. So this entire robot is kind of a loop like this. This basket back here stores 6 balls, sometimes 6 or 7, depending on how I choose to funnel them up. We can also hold about 5 in this front section. So for a total, we can have like 11 to 12 capacity if we need to, in which case we can kind of dump at the end of the matches, which actually kind of worked and helped us win a couple matches at Worlds. So yeah, back to this roller right here. These are cut 3-spoke flex wheels. They're both 38 durometers. And we use a 5.5 watt motor. It's just connected on the outside right here. And then there was also this poly flap right here, which is completely passive, but it essentially just allows balls to roll up against it because it's not able to move. I can push on it and it doesn't go this way, but it does go this way. So once I choose to do so, I can either press the controller so that it keeps the balls in, or it allows balls to come out like that. So obviously, usually I would be holding all the other buttons while I do that. So scoring would look like this. And then I can open the flap. So that's how that works. All right, so our aligner was actually put on a hinge. This was actually not really part of the plan. We kind of built this as like a rigid part of the structure and then realized halfway through building that when these came out, they would be too close to the match loader, or this would be too close to the match loader. So we actually had to put this on a piston to get it out of the way. And although this was a little bit of a waste of air, it wasn't really that big of a deal. It worked well. It kind of kept this out of the way when it didn't need to be there. And it worked very well. It's quite strong, especially when you're pushing on it this way. And it also actually protected our AI vision sensor, which played a huge part in our code. We actually used this to custom align to any part of the field, including the goals, the match loaders, and the center goals. So actually, I can actually just press the A button and it finds the closest game elements, only if it's obviously in view. Let's see what else. We had this. It's kind of like an exoskeleton. This is kind of just like a lazy attempt to protect this 11 watt motor, which was kind of just attached to the outside. We tried to put this on the inside, but there really wasn't much space, so we kind of had to do it this way. We didn't really have any problems, although obviously you can tell it's quite bent. Other than that, let's talk about the basket. Actually, of course, we have the brain. We decided to make our wiring a little bit more neat this year. So my programmer, Nahem, did a very good job wiring these. And then we have the brain on a slant, which was kind of cool. It just looks a little bit better. And normally we have a brain cover on this, but right now we kind of lost it at Worlds. And then the basket is, it holds 6 balls. We have this top roller up here, which is kind of just like the last roller in the intake, which just helps balls go from right here down inside to kind of make this jump. So I'll go ahead and load some balls and show you how the basket works. So that's 3 right there. And then I'll go ahead and put 3 more. All right, just like that. So the 6th ball kind of goes like up right here. This is why it funnels from staggered like this down into a single file down here. The mesh kind of blocks the view a little bit, unfortunately, but essentially the 2 balls stagger like this, kind of like I said, and down into one. We had a couple jamming issues with this, but ultimately it wasn't really that bad. They flow pretty smoothly. They didn't really get stuck too much. This was a limiter right here, which is made out of poly. It's very hard to see, but it essentially just reinforces that kind of curved D structure. So we kind of called this just a D-bot. We have this vertical section and then the D curve right here. And then of course that just goes back into the outtake part. So that was middle goal scoring, and it goes out pretty fast, works pretty consistently. Yeah, that's it for the basket. So one of the more complicated things on the robot was this kind of over-engineered gearbox. So the reason we had to do this was because we couldn't have one 11-watt motor control this roller, this bottom roller, and this front outtake. So our solution was to use two 5.5-watt motors. There's one back there, and then there's one right here. And these are kind of covered by mesh and rubber bands on this side, and then this curved poly piece right here for the basket. And the back 5.5-watt motor only controls this down here, which is just a combination of rubber bands and the cut 38 flex wheels. This worked really good for us. And then this 5.5-watt motor is doing a lot more heavy work. It's directly connected to this sprocket, which connects up to this 6-tooth gear. And this is I believe, 4-to-1 gear ratio. I may be completely wrong though, because it's been a while since I've built this, but that spins this in both directions. And because we also needed this to spin this sprocket up here, we had to put this on a separate axle. So we reversed the direction using this back here. So I'll spin it a little bit. Yeah, so back here, we use this gear ratio to just reverse the direction and speed it up a little bit, since this is a larger input to a smaller output. And then again, larger to smaller to just get this as fast as we could to prevent any backlog or jamming up here. And from the top, it's all pretty compact. It's well within the size of the robot. So yeah, this worked really well. It's very strong. It was actually really proud of this. It's very, very difficult. Lastly, we just have the D-score arm. This was pretty cool design. It's pretty similar to what everyone else has. The only thing that's different is that this kind of starts inside the robot, and then when this spins, it can come out. We have a single acting piston right here. So this can start down with the arm on the inside, and then as it comes up, the piston can activate, and then the piston goes up and down, which is what controls our D-score arm, obviously. Then we have this aligner right here, which is just kind of like triple reinforced with triangle bracing. We used a 68 durometer flex wheel after a lot of testing, because this is kind of good. It gives just enough compression for alignment. So if we come in at an angle, it can compress just a little bit while still rolling, while giving plenty of space to D-score like this. This was very consistent. It helped a lot at Worlds, and it worked really well. We just had a zip tie for limiting it, which of course is jank, but if it works, it works. So that's kind of our rule as we're building. And then this is our battery placement. It's also a little bit jank. We kind of just shift this out of the way when we're putting the battery in. We just use this to keep it in, and we've never had a single problem with this. So this was cool. Yeah, that's it for this robot explanation video. So if you have any questions, go ahead and put it in the comments, and I'll do my best to respond to everything. If there's any videos you want to see of the robot, or anything specific you want me to cover in any next videos, again, let me know in the comments. And yeah, we'll see you in Override. Good luck.